We'll start with a bit of magic there for Christmas, bit of physical and chemical changes there with flash paper. Do you use flash paper? Be careful, but it's handy. And then something sponge that is really all air. There's nothing there. But I mean, think about atomic particles and so on. Magicians often use these sponge balls, which can be put into a very, very small space. But of course, it's mostly air in those. But that's not really Christmas. Let's start with what we're going to do. It's really a set of experiments that we've adapted into Christmas with a bit of Christmas paper and a few little bits of elves and Santa Clauses. But that makes for a bit more interest in your lessons, I'm sure. There's a lot more that we could show you than we've got today. Some of them, many of them are on the Facebook What Happens Next experiment group. If you want to look further into those, just go into the Facebook experiments group, Facebook What Happens Next experiments group, and search December or Christmas. And that will take you to a lot of experiments that we've got today and some that we haven't got today because of various reasons. So the first little bit of Christmas trick that you can have is to have a Christmas box. Can be any box, but it's now Christmas because Santa Claus. And inside the box, you'll see there's absolutely nothing. Now you can adapt this to anything almost in your lesson. A nice thing to have on the desk to start when you're introducing something, because you can open the box, and although there's nothing inside, it looks as if nothing. You can put, oh dear, sorry, I got Easter instead of Christmas. So anyway, let's get some things out of the box for Christmas. Or we maybe have some teddy bears in Christmas colours. Or maybe you want to produce a treat for your class out of nowhere. So here we have a box of biscuits. Put it down. Or maybe a sweet treat. You could, of course, produce your exam results from a box like this that looks as if it's got nothing in. Or, since it's Christmas crackers for the class. They'll be thrilled if you got 30 crackers in this box. So what's in the box? It's very simple. I'm sure everybody knows. There is inside a mirror. Oops, another cracker. Inside a mirror at 45 degrees, and take it out. You can see the box. Plastic mirrors, easy to get, very cheap to make. And you're talking about the image in a plain mirror. I used to use, when I was teaching a long time ago, I used to use pins and things. But here you've got an actual image behind the mirror. There's other things you can use for the same thing. You can buy these things. There's an empty glass. Oh, so what have we got inside? This little Christmas thing. What's inside the glass? A mirror that is shaped so it fits exactly in the mirror. Object, image, same distance behind, and so on. Or other thing. You can buy these very cheap. You can buy little money boxes that are the same. There's another. There's a tube. Give it a shake, and there's the scarf inside. So that's sort of a little bit of Christmas, I suppose, magic you might call it, to sort of get us going. Nicer than some of the books that we read with the theory of images and objects in mirrors, to have these real things to use. So, as I said, we're going very quickly to get as many little experiments as we can. So now I'm going to stop, have a rest, and hand over to Ruth.
Hello everyone from Portugal. So I will start with the magic of this season, that are children and their wishes. So I will start changing here my camera. And I hope you all can see this letter. So Natalia, sorry, you just go to, So Natalia wrote to Santa, and her mom told her, Natalia, you can only ask for one thing, because Santa doesn't have room for more than one present per child. But Mom, I only choose one. You just can't see one because you don't have the magic of Santa. And today I bring the magic of Santa and these 5 wishes that are not wishes, these 5 ones. We have one wish here that I will reveal with the magic of Christmas, with a little bit of heat. So let's see. And so, what Natalia wants for Christmas is just peace. Okay. So I will change again my camera. The magic behind this. I believe that most of you already saw this and you know this. Probably your child, they use this kind of pen. It's erasable pen. It has an ink that is thermosensitive. So it will change color when the temperature is hot or cold. I choose this one. It's black. And I wrote everything that now you can't see with this magic pen. So with this pen, with this special ink. And then I use a normal pen to write the wish, the real wish of Natalia, that it was peace. And when I use the hairdryer, the ink, the sensitive, the thermal ink will disappear, and you can only see this one. So this is a nice one to do in Christmas time, and also you can talk about chemical reactions and equilibrium, and I hope you enjoy it. So I will pass to David.
A video.
Today's question is all about forces. Forces are invisible, of course, we can't see them really, but we can see strings and so on. And it's about a box and a balloon as well. So what we're going to do is look at the forces on this box. And the first part of the experiment, we just lower the camera so you can see a bit better. First part of the experiment is to move the box to the edge of the table. Now without the balloon, I'm sure you'd agree, it would fall over. But maybe the balloon is pulling it a little bit short, is that right, of the halfway mark. Is the balloon pulling it up? Right? So it doesn't balance right in the middle. But what happens if we put it the other way around? Can we get the box to the very edge of the table? How far can I push it? A little bit more, do you think? A little bit more? More? Wow. Just about to there. Gosh, look at that. I think my little puppet here is very impressed. Yes, he seems very impressed at that. Now, the question for you to ask, for me to ask you, and you to answer is, what will happen to the box if I cut the string? can you look at the forces that are acting? Can you draw a diagram? If you're clever, you can draw a diagram with arrows to show where all the forces are. How does the box stay like that? And what happens? What happens next when I cut the string? Okay, there's a nice Christmas question for you. I'm ready with my scissors to cut the string. So, what do you think? What do you think, you two? Are you watching carefully? Get ready and cut the string. Balloon's gone up to the ceiling. There it is. Gone up to the ceiling, and the box has stayed where it is. So how can that be? Well, I don't know whether you saw the trick, but what is inside the box are some tins. Christmas custard. And when I first did the experiment, the tins were in just about the middle of the box. So when the box tipped over, the tins slid to the far side, and I very subtly swapped the box around. So now the tins with their weight is at this end, so I can put the box over the side and it doesn't fall. So it's very easy when you know, but when you don't know, it's quite mysterious, isn't it? Just like these little men here. Quite a mystery how they work. So bye for now, and I hope you have a very Merry Christmas.
Right, it should be back to me and get my camera on. Right, okay. So here's another one, which I actually think is quite amazing, and it's to do with forces again. I've got my Christmas bag, and what do I do in my Christmas bag? I do my Christmas shopping. So I've got, you may have seen this one before, got a nice English Christmas pudding, which is quite heavy. This is 400 grams in the bag, and hook it over a little hook I've got, and I have a nice spoon here, and I start usually by asking how many times do you need to wrap the string around the spoon before it holds, and we go 1, 2, 3, slipping, and number 4 it just about holds, but 5 it definitely holds. So nothing extra, just the friction, force down, friction at the top, you can see quite well, and 5 turns holds the bag. Just hold it with my finger now and get a second Christmas pudding. Oh, we're going to have fun. Well, actually, we're doing, I've got an old people's Christmas lunch tomorrow, and they're getting these Christmas puddings. So that's 2 in the bag. You can see I've got 2 in, no cheating. And the question I ask is, how many times now will I have to wrap the string around? We know that 4 just won't about hold it. 3 certainly won't. There you go. 3 won't. So we got 5. So will we need twice the weight? It's obvious, isn't it? We need 10 turns. Is that right? 10? Let's try. 4, 5. That was what we had before. Oh, and it's still held. How is that? Well, and it's nice to draw force diagrams on these things because you've got your force of your hands and so on as well. My force of my hands is 800 grams. There's 800 grams weight. Sorry, we're not in correct force units, but 800 down there. The harder you pull down, on the string, the greater the friction. Right? That's right, isn't it? You know, think of friction, and the bigger the force down, the bigger the reaction, the bigger mu r, and so on. So that's amazing. I think that it's exactly the same number. Let's be really ambitious, and somewhere, oh yes, because we've got 30 old people coming. I know I'm one of them, but I'm on the dishwasher. So we've now got a giant 800 gram pudding. Let's put that in. Is there a limit? There must be a limit to how much. But will 5 hold this? That's 1600 if I do my maths correctly. 5 turns, and there we go. So there we are. So that's an interesting one, because I think most people think you'll need a few extra turns to hold the spoons. But a nice one to do. I sometimes use a nail for that, a big 6-inch nail. What is it, 15 centimeter nail? And you can experiment with different thicknesses, different widths of spoons. That's it. Can you try this? And it somehow, it nearly always works out. About 5 turns is enough to hold anything. You can get your older students to work out why is it about 5 turns. And so on. So that's a nice little experiment. Take these to church tomorrow to make the lunch for the old pensioners. That's the over 70s, but I'm one of them as well. Don't feel it. Okay, now another video to show you from Kirsten. Thank you, Kirsten, in Holland, in the Netherlands.
It's Christmas time, and it's time to do some experiments with candles. So I try to make my own seesaw. I do this with 2 candles, and I put them together and push a little bit until it's cold. And then I take a needle, warm it a little bit up, and put it just through the middle. And it goes down, and I have my own seesaw. I hope that's a bit in balance. Yes, it is. And now the question is, what happens if I light the candles? And I will first light this one, and then the other one, and we will see what happens. Obviously they both burn. And as you see, the one that is down loses more wax than the other one, so it becomes lighter and lighter that side. And in the end, the other one starts to drip also, and they just do this, and they have a little seesaw. And the nice thing is that this is quite slow, and I have done this earlier with another 2 candles, and they are here, and I burned it quite a long time. And you will see that they move much quicker if I turn on these. I light these candles. So they do the same thing, but just much quicker. That's it.
Thank you, Kirsten. Talking of candles, I've got a candle here. Right. There we have it. A nice little candle burning brightly. Now, I don't recommend this to your students, but you can actually try it. Candle burning bright. Things aren't always what they seem. So what was that? It wasn't a candle at all. There's the candle with wax. I made that candle with an apple galka. Put the galk through. There's my candle, just cut it. And then the wick is actually cut from blanched almonds, the little almonds there. So that was a bit of a cheat, but it makes you think, what am I watching? Don't believe everything you see. It's a party trick. Okay, next one. I'm sure everybody is thinking about decorating the tree. I know my son, they get their tree up on Advent Sunday and it's all decorated. They've got lights outside the house now. We tend to wait until nearly Christmas Eve. Our friends, I know in Norway, don't do anything until Christmas Eve. And exciting. Welcome, friends from Ukraine this year, because you're celebrating Christmas the same day as we do in the West this year. So a very happy Christmas we wish you, and certainly peace to your country. But so if you're decorating your tree, that was a bit of a diversion. You may have these beads, and the question is, what happens if I drop the beads over the side and let them fall? I'll just go behind so you get a better view of this. And I must make sure the beads fall to the floor. What happens when the beads come down? Now, what happens next is that the beads falling down get faster and faster. And so as they get towards the ground, they're actually pulling the other beads out of the jar. So what I expect to happen is the beads start to come out of the jar just over the side, and then towards the end, they're actually jumping up right above the jar. Let's see if it works. Sometimes these things work better than others. Just pull it over the side. You see it going up? Didn't go very high that time, but it does sometimes go way high as the pull of the beads down pulls the beads up. I don't think this one works so well. If I can find the end. Can't even find the end. There we go. So this goes down. It jumps above the beaker. There, right. So that's, now we're doing well. We're bombing through. So I'll pass over to Ruth to do her next one.
Okay. Thank you, David. So if you already decorated your Christmas tree, I'm sure you used your Christmas lights. And so I bring here, I'm going to change my camera again. Okay. Just, oops, didn't change it. Let me see. So sorry. So I have here a Christmas tree. I choose a red one. And I have here Christmas lights. I know that online with your computer, it's a little bit difficult to distinguish the colors. So I will have some pictures in a while to show you. So I have here a green, a green light, a red light, a blue light, and an orange light. And the question is, what happens if we look with the red filter? So what happens? Will all the colors look the same? Will the Christmas tree look also visible and red? Let's see. So I will put a red filter in front of the camera. And I believe you can see that some lights look, they bright less. So some of them are really, really bright and others much less. So this one is blue. You see? So the light is not so bright. And this one is red, this one. And it's very, very bright. So why this happens? So a red filter transmits only red light and absorbs all other colors. So if I'm using a red filter, I will see only red and black. Well, I didn't saw black here because this is a light, but if I have another color, probably you will see black. So we can do this experiment with the rest of some sweets in Christmas. So eat the chocolate and use the paper to make experiments with your friends, with your kids, with your nephews. So I'm going to take this and use again a red filter again, and looks like we don't have a tree because this filter only lets the red light pass, so you will see the white paper red and the Christmas tree red also. So red with red, and we have a kind of camouflage. If I use another filter, a blue one, you can see perfectly the tree looks like almost black, and you can see the paper blue. So I will just show you the image. Just a minute. We have here on the left a blue light, and you can't, on the right, you can't see almost no color. The same with the green, and the yellow and red, they bright a lot with the red filter, and see the same image. You see, I can't see the Christmas tree in this one, so it's the same experiment, but I think with these pictures you can see better. And then using a blue filter, our Christmas tree looks black. And for primary teachers, this is an idea you can do with your kids. A letter to Father Christmas or to Santa Claus, and they can draw with a blue pen what they want for Christmas, and then they can scribble with red around, and then they use a special filter to see what they want for Christmas. So this is an idea for primary teachers, or also for teachers that have small kids. They can do. So for this experiment is everything. It's done. I hope you enjoy it. Thank you.
Here I am again. Yep. Okay. Christmas wouldn't be Christmas without a few balloons. And I'm sure you're familiar with one of my favorite What Happens Next experiments. But now I've got Christmas balloons. Wow. So 2 balloons joined by an inline tap from the garden centre. And the question which I always ask is, what happens next when you open the tap? Will the big one blow the little one up? Will the balloons equalize? Or will the little one blow the big one up? or will nothing happen at all? Will they just stay? I would say inevitably, or nearly always, if you have an audience who hasn't seen this, they will say the balloons equalize. But in fact, they don't. The little one blows the big one up. And you know that, you can deal with that with all ages, because when you start to blow a balloon up, when do you have to blow the hardest? When do you have to puff in hardest? When it starts. Often little children will say, "Mummy, teacher, will you start the balloon?" And that's because the pressure inside the balloon is greatest when the balloon is small, starting. What happens is you've got to untangle the long molecules, and then you pull them apart. Once you get the balloon going until the very end before it bursts, it becomes much easier. So you can do that. Then you can perhaps try something else. If we let this one down, that's the balloon, like me. If you have two balloons, even if they were equal, and you try and blow them up together, one will always start first. Because as soon as it's bigger than the other one, the pressure inside is less. Older students could actually plot graphs of pressure inside a balloon. They can also look at how the pressure is affected once the balloon's been blown up. So one will always start first, and then the other one doesn't get going. Now, if you like balloons, I like balloons. Some children get very worried about balloons because they think it's going to burst. There are some games you can play using balloons, which I just sort of suggest to you. I don't know if you've come across these little tiny balloons, water bomb balloons. Well, we don't like throwing water bombs, but we like playing with these balloons. And you find if you blow them up with a pump is best because the air inside the pump is dry, and almost as you blow them up, they will become charged. See, that's sticking to me. I can stick it on the head, or I can stick it anywhere, in fact. And the game is, if you give people enough balloons, and you can see how many they can stick on their persons and so on. So that's a game with these little balloons, easy and cheap. All you need is a balloon pump, although you don't really need a balloon pump, and a few of these. You get about 100 in a packet for a couple of euros, so that's fine. Now, sort of get rid of those. It's important, if you're actually demonstrating this in a lecture and you go on to something else, you don't forget to take the balloons off your head, because you look a bit stupid when you're doing that. But I've not forgotten that, so that's okay. Now, the other thing with balloons, another little game you can play, is using paper cups, or any cups. You can actually use glass cups, glasses as well. If you take, did I have a balloon there? Christmas balloon, Christmas mug, so it's a Christmas experiment. And the test here now is to see in competition with each other how many cups you can attach to the balloon. So start the balloon off. Now that balloon is going quite a way inside the mug. So when I blow it a bit further up, put more air in, the balloon curvature gets bigger, or less. I'm not sure whether to call that less. The curvature is less, but the center of curvature is a long way away. Put it there, and amazing. You can do this with glass cups, but oh, it's come off. Let's start again. Get one on. Two. Without the first one falling, I'm not doing very well with that, but you can see the idea. It's a bit firmer. The bigger the balloon, the harder it gets. So how many of these cups can you stick on? Another one that I do quite often is the Smarty Tube experiment. We've got two beakers here, a placemat, slippy, rough, and put the tubes, the sweet tubes, on the top. They always fall over when you're in a little bit of a hurry. So they're above because now normally I use bean bags, but because it's Christmas, look what we've got to put on top. Put these little men on top. And the idea is to get the men into the biggest below by knocking the placemat away. Physics. The lower part is smooth, so it slips off the containers below. The slightly rough cork part is sufficient friction to move the light, very light Smarty tubes out the way. And the man, who's got no other force but gravity on them, will fall down to the bottom. And I'll get them in the beakers. This is really good for children to try because it is actually easy to do, although it looks quite difficult. Ready, steady, and there you are. You should all be applauding now, but it actually was just physics. Very easy. Right, so that was forces, and now the last experiment I've got sort of in this line is to use anything that we can find that's Christmassy in the Christmas. So here's my Christmas toilet paper. You come to our house. We actually I bought some new toilet paper as well. Bright red toilet paper. Wow. You can get different colours in this. These came from Portugal. How about all those different colours? There's only a snag about it. It says on the back, beware if wet, not suitable when wet, which seems a bit strange. So, we've got a song that we sing in England, Rudolph the Red-Nosed Reindeer. So I don't know what this will be, Rudolph the Red-Nosed something else if he uses it. But anyway, you can get nice red toilet paper. I haven't really thought of many experiments to do other than shine lights on the different colours. But we'll do this where we have. Did I have a spoon somewhere? Yeah. So I've got my noble assistant Andrew. You can see his hands there. All right, who is going to hold the toilet paper. And I've got a couple of books here, and big heavy books. One about the Universal Encyclopedia of the Bible, the biggest books we've got. Put the toilet paper on, and then I'm going to drop the books, and I want to know what will happen to the toilet paper. Will it pull down all the way as the books go down? Will the books release the toilet paper or something else? Now this is about free fall. So if we let's try not to drop it on my Christmas puddings. Are you ready? Watch the toilet paper carefully. 1, 2, 3. toilet paper just stays where it is. Why is that? Because the upper book becomes weightless compared with the lower book, so it's not exerting any force on them. Is there anything else you can do with toilet paper? Yes, there is. There's the dropping experiment you can try. If you drop a roll of toilet paper, it stands on its end on a good hard surface, so that one doesn't. It does work with this. See, it stands up on itself. Now, the smaller the cylinder gets, the harder it gets to do. So there we go. So that's another extra. That was just something else you can do with toilet rolls. Pew, over the route.
Okay. So just adjusting here for you to see better.
Going to play with it.
So, remember Natalia, the little girl who asked for peace in the world a few minutes ago? She has a sister, a small sister, and she asked a toy for Christmas. So let's see what she asked for. Can you see what the little sister of Natalia asked? No, because we need to use the Santa water. Let's use it and see if we can discover what Natalia's sister wants for Christmas. She wants a fire truck. So I'm using here, now this is the science part, I'm using hydrogels. They have water inside. And when you only have hydrogels between them, inside of the box in the beginning, I only have hydrogels, and between them I have air. And light travels with a different velocity in different mediums. So water travels faster in the air and slower in the water. I couldn't see the fire truck before because light was changing direction, and so I could see something blur. When I add the Santa water, I took the air between the spheres and between them I only have water. So the medium is exactly the same. The hydrogels with water and water between them. So the light will travel in a straight line, and we can see perfectly what Noah, Natalia's sister, wants for Christmas. Thank you. Passing to you, David.
Yes, those hydrogel bubbles you can purchase at a garden centre quite cheaply as water bubbles, they call them, and they come as tiny little beads, which when you leave them in water for about an hour or so, they swell and swell. It's interesting watching them, water bubbles from a garden centre, which people use to store the water for their plants, put them in, and you can see, I think there's a picture on the front of how you can keep your plants watered when you go on holiday in the lovely warm summer. We're just about finished now. There's several other little bits and pieces we could do. I wanted to mention the poinsettia plant. The poinsettia leaves, the red leaves, act in the same way as red cabbage as a pH pH indicator, I can't say the word, pH indicator. So when you're finished with Christmas and the leaves start falling, take some poinsettia leaves, scrunch them up and make the indicator. That's one thing that we did. The other thing that I didn't mention when we're doing free fall and so on is it's always nice to drop different things and get children to discuss, you know, the different forces and the different accelerations. I find I get tremendously different reactions to when I try and drop different things. So if I have, for instance, 2 teddy bears, hold them upside down, heads at the same place, and about to drop them, there is uproar in the class, especially from certain quarters, that you can't try and drop the teddies. So say, all right, we'll not drop the teddies. Since it's Christmas, we'll drop our Santa Clauses. So you get Santa Claus and about to drop him. You can't drop Santa Claus because we'll not get anything at Christmas. So I have to go and revert back to my bean bags and something else, which is really boring, but it's nice to drop all sorts of different things. I've got one more little video at the very end. Have you got anything else? Ruth, we've got 10 minutes so we can answer any questions. We'll both stay on now.
Yes, if you don't mind, David, I have a very small one. I may be changing
That's great.
the camera. It's easy. Let me just change it. This is just a challenge. Okay, you can do it with kids, adults. So Santa, he has a problem. Since last Christmas, he eat too much sweets, and so he gets a little weight, and he needs a new belt. The problem is he only has a small piece of fabric, like this, a very small piece of fabric. How can Santa, only with this, and with a scissor, produce a belt, a bigger belt? Because he needs to go and he needs to have the trousers on the right place. So you can give this challenge to your students or to your friends, and I will give you the solution because we don't have so much time. You cut the paper or the fabric and you fold once, and then you cut. I hope you can see, like this. So with the scissor, you cut from here to here, and you do lots of cuts. If you do it much more, you'll have a bigger belt. And then you do the same from here to here. Okay, so this is the first part. The second one, I already have this prepared. Okay. And then, oh, this is the final one, sorry. You cut, and then you just need to open it, okay? And when you open, can you see, you can cut with the scissor, sorry, this is a mess. You can cut with the scissor in the middle, okay? In the middle, all of them. Not the first one and not the second one. So you will cut here. And in the end, you have a huge belt for Santa. So this is a nice thing to do, just a small challenge with a piece of paper and with a scissor, and ask kids and see the kids doing, they are so creative, they cut around and everything. Give them time in the last day of school for them to figure out how can we just this and a scissor have a seat belt, or a belt for Santa. That's it, that was my extra. And if
thank you. You can see, I'm in the mood already. I'm right in the mood for Christmas after doing those experiments. we'll just show one final video with our final message to everyone.
Well, here we are with our bowl and with our water. Remember, we've got in the bowl our water beads, and we pour the water in, and the beads, which were distorting everything like little lenses, you can't see anymore. You can see straight through them because we call it the refractive index of the water and the beads is the same. And so you can now read my Christmas message to everybody. Peace, love, and joy to the world. Glory to the newborn King. So have a lovely Christmas and a happy New Year.